Hello viewers, in today's class we are going to discuss an important limit involving the greatest integer function, absolute value function and fractional part function, right? So here we have to find the value of this limit, that is limit x tends to 2 plus fractional part of x plus 3x divided by mod of x minus 1 plus greatest integer x plus 1, right? So here if we take this as a function, then we have to find the right hand limit of this function when x tends to 2, right? So now let us first call this limit as L, and here what we will do, will make use of the standard definitions of absolute value function, greatest integer function and fractional part function to evaluate this limit, right? So let us start, right? So first what we will do, we'll put x is equal to 2 plus h, right? See here x tends to 2 from the right side of 2. It means we have to find the right hand limit of this function when x approaches to 2 from the right of x is equal to 2, right? So let us put x is equal to 2 plus h. Now here h is a very small quantity and greater than 0, right? So viewers, here one important thing is that when we substitute x is equal to 2 plus h, then this h, this is a very important quantity, right? And this h is greater than 0. It implies that h is a positive quantity, positive number, but it is very small, right? Okay, so now when x tends to 2, obviously h tends to 0, right? So now making this substitution, x is equal to 2 plus h, this limit L is now equal to limit h tends to 0, and here we have fractional part of 2 plus h, and here we have 3 times x plus here we'll have 2 plus h, right? And in the denominator we have a mod of 2 plus h minus 1, and here we have greatest integer 2 plus h plus 1, right? So now this limit L, it becomes like this, and now we can simplify it a little bit. So limit h tends to 0, and here we have the fractional part of 2 plus h, and here we have 3 times 2 6 plus 3h, and in the denominator we have a mod of 1 plus h, and here we have greatest integer 3 plus h, right? So now this is a very important step, right? And here we have to make use of the standard definitions of fractional part function, absolute value function and greatest integer function, and let us see how we can do it. So now let us first take this fractional part function, right? So here we have a fractional part of 2 plus h, right? So viewers, we know that the definition of fractional part function is the fractional part of x is given by x minus greatest integer of x, right? So this is the definition of fractional part function, and we know that the domain of the fractional part function is R, that is the set of real numbers, and the range is given by this interval, that is 0 comma 1, or this can also be written as x greater than or equal to 0 but less than 1, right? Okay, and the period of the fractional part function is 1, right? So we'll make use of this definition to express this function, right? So now if we take x is equal to 2 plus h, over here, then we see that we have fractional part of 2 plus h is equal to 2 plus h, and here we have minus greatest integer of 2 plus h, right? And now we have to make use of the definition of greatest integer function to evaluate or to express this quantity, right? See, here inside this brackets we have 2 plus h, right? So 2 plus h, and we have already said that h is a positive quantity, but h is very small, right? So if we take h is equal to say 0.001, then 2 plus h is 2 plus 0.001. Here we are taking just for example, so this is 2.001, right? So the greatest integer of 2 plus h is now equal to greatest integer of 2.001 if we take, for example, h is equal to 0.001, and we know that 2.001, the greatest integer of 2.001 is simply 2, right? So here we can write 2, so we have 2 plus h minus 2, and 2 and 2 get cancelled, and we are left with only h, right? So here we'll take the fractional part of 2 plus h is equal to h, right? Now let us take the absolute value function, right? So here we have a mod of 1 plus h, right? So viewers, here we are taking step by step each concept, and here we see that inside these two vertical lines we have 1 plus h, right? Now 1 is positive quantity, h is, we have already said that h is very small, but h is greater than 0, it means h is also positive. So 1 plus h is a positive quantity, so by definition of mod function, the mod of 1 plus h is simply positive 1 plus h, that is 1 plus h, right? So here we can simply write 1 plus h. So here we'll replace this mod of 1 plus h by 1 plus h, right? Okay, now let us take this quantity. So this is the greatest integer function, and here we have the greatest integer of 3 plus h, right? So again we can explain it on similar lines. So we have see 3 plus h. Now 3 is positive, h is also positive, right? We have already said that h is greater than 0, it means h is positive quantity, but it is very small. So again we can take h is equal to 0.001 just to evaluate this quantity or to find the value of a greatest integer of 3 plus h, right? So we have 3 plus 0.001. We can take any value of h which is very small, right? So here we are taking it just for making the concept clear, right? H is equal to 0.001, so this is 3.001, right? So what is the greatest integer of 3 plus h? So the greatest integer of 3.001 is simply 3, right? This is due to the definition of greatest integer function, right? So the greatest integer of 3 plus h is 3. So here for greatest integer 3 plus h, we can replace this quantity by 3, right? So now viewers, we can write this limit L as limit h tends to 0, and for the fractional part of 2 plus h, we can write h, and we have 6 plus 3h, and in the denominator we have mod of 1 plus h, which can be written as 1 plus h, and for greatest integer 3 plus h we can write 3. So here we have 3, right? So now we can easily simplify it. So limit h tends to 0, 3h plus h is 4h plus 6, and here we have 3 plus 1 4 plus h. Right, now here we see that this is a fraction, that is a rational function in h. So now we can simply substitute h is equal to 0 over here. So we have 4 times 0 plus 6 divided by 4 plus 0, and this is 0 plus 6 over 4, that is 6 over 4. Right, so the limit is 6 over 4, that is 2 3s are, this is 2 2s are 4, so this is 3 over 2. Right, so viewers, the value of this limit is 3 over 2. Right, so this is how we evaluate this important limit, which is a combination of fractional part function, absolute value function, and the greatest integer function. Right.